Welcome to the course on C programming. In this video, we will be discussing about input-output functions in C. And input in any programming language means to feed some data into a program. This can be given in the form of a file or from a keyboard in a command line. Similarly, output is used to display some data onto the screen, printer, or into any files. For these input output operations, or what we call as IO operations, we have something called as standard C library. The standard C library provides a set of input output functions for the programmers to use. The standard C library is kept in stdio file, and you have to include this as a header file in our program so that we can use all the standard input output functions. The main input output functions can be categorized into formatted functions and unformatted functions. Formatted functions classified as scanf and printf. Scanf is for reading the input, and for printf is for displaying the output. It can be used for all the data types. Unformatted functions, we use getch, getche, and getCharacter for reading input characters, and putch and putchar for outputting or displaying character data types. We do not have unformatted functions for int and float. Getters and putters is used for inputting and outputting string data types. Now we move on to the formatted IO function, printf. Printf is used to write output data. A printf function has got the following syntax: printf format string, comma, list of variables. This format string or control string actually consists of three parts: characters that are simply printed as they are, conversion specifications that begin with percentage symbol, and escape sequences. So consider this example. Here you can see that this printing corresponds to the characters that are printed as they are. Then %C, %S, %D, %F corresponds to the conversion specifiers. /n is a type of escape sequence. There are many more escape sequences available. So the output of this will be printing. Then %C is the first conversion specifier. This will print the value of the first argument. Second conversion specifier will print the value of the second argument. Third conversion specifier will print the value of the third argument, and fourth conversion specifier will print the value of the fourth argument. So the values of these arguments will be printed, then followed by /n, which corresponds to a new line escape sequence. There are many more escape sequences like /t, which corresponds to tab, then /b, /r, etc. Now, this conversion specifier we will see in detail. A conversion specifier can take this particular format: percentage, flags, width, dot precision, length specifier. Whatever is given in square brackets here, that is flags, width, precision, and length, they are optional arguments. You need not specify them. Without them also, the specifier will work. Now we will see what are the available specifiers. If you want to print a character, you will use %C. For decimal, you will use %D. For floating point with exponent, you will use %G. For floating point, you will use %F. %I for signed decimal number, %O for octal, %S for string, %X for hexadecimal number. Now, we will see the optional arguments. The first optional argument was flag. Flag can take these values minus, plus, hash or 0. Minus, if you add a flag minus, your output will be left justified. If you add a plus to your printf specifier, then it will display the data with its numeric sign, that is either plus or minus. Then hash is used to add specifiers for hexadecimal and octal numbers. You will see how it is done. Then if you add 0 to your specifier, you will be adding zeros to your number instead of spaces. You will be left padding zeros instead of spaces. So we will see these two flags in detail later. Now we will discuss about plus and hash. Suppose I have a number 12 and I want to display its hexadecimal value. A hexadecimal value is a number which has base 16. The hexadecimal value of 12 is C. So if I do printf percentage x comma 12, the hexadecimal value of 12, which is C, is printed. Now if I add the flag hash to x, then the C will be prepended by something called as 0x to denote that it is a hexadecimal number. So you will be printing 0xC. Now if it is an octal number, okay, suppose I am printing 7, printf percentage O 7. Octal of 7 is 7. So when I print it, 7 will be printed. If I put a hash, what will happen? Percentage O 7, hash O 7, it will print octal O 7. Okay. So that is about hash symbol. If it is hexadecimal number, if you use a hash, your number will be prepended by 0x. For octal, if you are using hash before O, then it will be prepended with O. Okay. Now if I have a flag plus, if I am printing printf percentage plus d comma 3, then it will be printing plus 3 because I want to print the numeric sign of my number. Numeric sign of number is plus, so that is printed. Next optional argument is the length modifier. Length modifier is used when we are using terms like or keywords like short int, long int, etc. So if you are using a short int or unsigned short int, you should use percentage HD. If you are using a long int or unsigned long int, you should use percentage LF. If you are using a long double or floating point long, then it is percentage capital LF. So you can see here, if I is declared as a short int, then you will use percentage HD. If you are declaring I as long int, you will use percentage LD. Next is precision. Precision modifier has different meanings for different specifiers. That is, if it is for float, it has one meaning. If it is for integer, it has got another meaning. In case of floating point numbers, the precision modifier determines how many digits have to be printed after the decimal point. So if I write percentage 0.3f, then it will display 1.2 followed by 2 more zeros because I have asked to print 3 digits after the decimal point. So here I have 1.2, only one digit after decimal point. but I have asked to print 3 digits. So after 2, I will add 2 zeros. Okay. Suppose if your precision provided is less than the number provided, if it is 1.2348. So here I have 4 digits, but precision is only 3. Then I will round the number and display. So since this is 8, this will be rounded to 1.235. Then if it is an integer number, if you provide a precision modifier, it will control the number of digits printed. So if I give 0.3d, that means I should print 3 digits. Okay, but my number is only 10. I should print 3 digits. That means I will be left padding zeros. So 010 will be printed. Okay. In case of strings also, it will determine how many characters have to be printed. So if I give 0.5s, it will print only 5 characters. That is A, B, C, D, E. This will be the 5 characters that will be printed. F and G will not be printed. That is precision. Thank you.